Hey everyone, and welcome. Today, we are diving into logistic regression. And trust me, this is one of those statistical tools that is an absolute game changer for researchers. If you've ever wanted to really dig into questions that have a simple yes or no answer, well, this is for you. Let's get right into it.
So you're probably pretty familiar with things like linear regression, right? You use it to predict outcomes on a continuous scale, like how your years of education might predict your income. But, so many of life's most fascinating questions, they aren't like that. They're about choices or events that either happened or they didn't. And that is exactly the problem that logistic regression was built to solve.
So here's our game plan for today. We're going to start by seeing why a straight line isn't always the answer. Then we'll learn the special language of probability, odds, and ratios. After that, we'll decode what the results actually mean. I'll show you how to avoid some really common pitfalls. And finally, we'll see how it all comes together to tell a powerful story with data. Just think of this as your pre-game warm-up, the big picture you need before you even crack open the textbook.
Okay, first up, moving beyond that straight line. We're stepping out of the world of simple linear predictions and into a new space. A space where the thing we're trying to understand is a choice, an event, or a state of being, not just some number on a scale.
So what is it really? Well, at its absolute core, logistic regression is designed for one very specific situation. When the variable you're trying to predict is binary. It's a yes or a no. It happened or it didn't happen. It's that simple. And in our data, we just code this as a 1 for yes and a 0 for no.
And this right here, this opens up a whole universe of really important research questions. I mean, think about it. Across public health, social justice, political science, education, you can essentially take almost any of these critical, category-based questions and turn them into a powerful yes or no outcome for your analysis.
Okay, so if we're going to understand the results we get, we have to learn to speak the language. And for logistic regression, that language is built on 3 key concepts: probability, odds, and the big one, odds ratios. Let's break each of these down.
We'll start with the one you definitely already know, probability. It's just the likelihood of something happening, right? It's always a number between 0 and 1. The easiest way to think about it is just as a percentage. So a 25% chance of rain, that's just a probability of 0.25. Simple.
Now we're going to build on that to get to something a little different, the odds. Odds are a ratio. We take the probability of an event happening and we divide it by the probability of it not happening. It's a direct comparison of something occurring versus not occurring.
So why do we take this extra step from probability to odds? Well, it turns out odds have this really neat mathematical property that's super useful for modeling. Probabilities, they're stuck between 0 and 1, but odds, they can go from 0 all the way to infinity, which gives us a lot more flexibility. And that brings us to the star of the show, the odds ratio. Now listen up, because this is the crucial part. An odds ratio is not the odds. It's a ratio of 2 completely separate odds. We use it to compare the odds of something happening for one group against the odds of it happening for another group.
Now, I know this might sound a little complicated, but the logic is actually beautifully simple. It's really just a 3-step process. First, you find the probability for your 2 groups. Let's call them Group A and Group B. Second, you convert each of those probabilities into odds. And third, you just divide Group A's odds by Group B's odds. And that's it. That number you get is your odds ratio.
Let's make this real with an example. Using data from the General Social Survey, we can look at depression diagnoses by gender. You can see the raw numbers here. The probability for males being diagnosed is about 18%, and for females, it's almost 32%, so a noticeable difference. Now let's run those numbers through our 3 steps.
And here it is. This is our final result. After calculating the odds for each group and then dividing the odds for females by the odds for males, we get an odds ratio of 2.09. So, what does that actually mean? It means the odds of females being diagnosed with depression are 2.09 times the odds of males.
Okay, so we've got our number, 2.09. But what do we do with it? How do we take that number from our software output and really, truly understand what it's telling us about the world?
Well, a great way to wrap your head around this is to compare it back to linear regression. Remember the slope? That number told you how much y changes for every 1 unit change in x. Well, the odds ratio, which you'll often see in your output labeled as XPB, is kind of the same idea. It tells you how the odds of y change when you move from one group to another.
In fact, you can use this table as your go-to cheat sheet. If the odds ratio is greater than 1, it means your group has higher odds of the outcome than the comparison group. If it's less than 1, their odds are lower.
And what if it's exactly 1? Well, that means the odds are identical. There's no difference between the groups at all.
Now here is a fantastic pro tip from our source material that I absolutely love. For odds ratios that are kind of close to 1, talking about them in times can feel a little clunky. A much clearer way is to convert it to a percentage. You just subtract 1 and multiply by 100. So an odds ratio of 1.13, that's a 13% increase in odds. An odds ratio of 0.48, that's a 52% times decrease in odds. See? It's just so much more intuitive.
All right, this next part is super important. Let's talk about some of the most common interpretation traps out there. I really want to help you sidestep these right from the beginning so you can talk about your findings with total confidence.
You're going to hear this kind of phrasing all the time. I mean, even in published articles. Someone sees our odds ratio of 2.09 and they'll say, females are 2.09 times more likely. And, I mean, it sounds right, doesn't it?
But it's wrong. As the author of our source material points out, they were once gently corrected on this exact thing by a peer reviewer. An odds ratio is not a likelihood. See, the phrase more likely implies you're comparing probabilities, and that is just not what an odds ratio does. Here is the correct, precise, and accurate way to say it. You have to use the word odds. You are always comparing the odds of one group to the odds of another group. It might feel a little wordy at first, I get it, but it is the only way to accurately describe what that number really means.
So we've got the theory down, we've learned the language, and we know what traps to avoid. Let's finish up by seeing how this all gets used in practice to answer a real, complex research question.
So here's our research question, pulled straight from an example in the source. We generally know that being married often correlates with better mental health. But it's also linked to social class. So, is the marriage effect real on its own, or is it just a reflection of class differences? Logistic regression is the perfect tool to untangle this exact kind of puzzle.
And check this out. Here's the story that the data tells. The full model reveals some really fascinating stuff. Even after we account for social class, being married is associated with 38% lower odds of depression. Age is a huge factor too. Younger adults have odds over 3 times greater than older adults. Being female increases the odds by 35% compared to males. And look at this, being middle class is linked to a massive 74% reduction in the odds of depression compared to the lower class. See? Each of these findings is an odds ratio, translated into a clear part of a much bigger story.
So, you see, logistic regression isn't just another statistical test on a checklist. It's a whole new way of asking and answering a different category of questions about all the yes or no outcomes that shape our world. Now that you've got the big picture, the only question left is, what story will you uncover?